going to draw 4 free body diagrams. First one, I'm going to draw one for each mass, and I'm going to draw one of this knot right here. I'm going to draw a free body diagram of that. So let's start with mass number 1. So for mass number 1, I'll put it over here. I'll do, M1G, pretend that goes straight down, and tension number 1. So this is tension number 1 right here. And that goes around the pulley, and so that's tension number 1 over there too. Now for mass number 2, I'm going to have M2G going down, and I have another tension which I'll call tension number 2. That's in this string, so that's also over here. And then for this third mass down here, I have M3G pointing down, and then a third tension, tension number 3. So that's tension number 3 right there. And now if I want to draw a free body diagram of this knot, I'll put that over here. I'm going to have that, which is tension number 2. I'm going to have this, which is tension number 1. And I'm going to have this, which is tension number 3. All right? Then when I bring in my coordinate system here, I see that I'm going to need this angle here, which is this angle there, theta 2. And I'm going to need this angle here, because I always find the angle between the slantwise vector and the x-axis. So this is theta number 1. So in this, which is the most interesting free body diagram, I can write an x equation and a y equation. The x equation has these two vectors in it, the two slantwise vectors. So I'm going to have t1 cosine theta 1, but because that one's pointing to the left, I make it negative. And then I have from this one t2 cosine theta 2, and that one has to be positive because it's going to the right. And we know this is equal to 0 because it's not moving. Then for the y equation, I have t3 pointing down. That's minus t3. And then I have these two vectors, which are both pointing up in the y direction. So I'm going to have plus t1 sine theta 1 plus t2 sine theta 2. And that's going to be equal to 0 because the knot isn't moving. Now if I look at these other 3 free body diagrams, I can pretty quickly get these equations. T1 minus M1G equals 0, which tells me T1 is equal to M1G. From this one, T2 minus M2G equals 0, which tells me that T2 is equal to M2G. And lastly, same thing for T3 and M3. Okay, so I plug that into these two things into the x equation. It's going to come out saying, because the m's are all the same, right? And if the m's are the same, then we have, and I'll just call it m instead of m1, m2, and m3, then I'll have minus mg cosine theta 1 plus mg cosine theta 2 equals 0, which is going to lead me to the conclusion that cosine theta 1 is equal to cosine theta 2, which has to mean that theta 1 equals theta 2. So then using that information, I'm just going to call it theta now. Using that information, I can plug in here and find out that minus m3g plus mg sine theta plus mg sine theta again equals 0, and then I can finish the calculation.